In our digital world, there's this invisible force that's working around the clock, 24/7, to protect our every single move online. Think about it. Every time you send a quick message, buy something online, or just check your bank account, it's there. In all those moments, there's an invisible shield protecting you. But what is it really? And how in the world does it actually work? Well, today, we're going to pull back the curtain on this digital magic.
All right, let's get right into it. This shield, it's called cryptography. And at its heart, it's really just the art of keeping secrets. It takes your normal, readable information and scrambles it into a secret code, a jumble that only the right person can ever hope to read.
Okay, so first up, we've got something I like to call the same key locker. The technical term is symmetric cryptography, and really, the name gives you a massive hint about how it all works.
Just imagine this. You've got a locker and one single key. You write down a secret message, you pop it inside, and you lock it up. Now, for your friend to read that message, they need an identical copy of that exact same key. See? One key locks it, the very same key unlocks it. Pretty straightforward, right? And you literally use this every single day. That Wi-Fi password you type in to get online, that's you and your router using the same key to talk to each other. Same deal with those apps that let you encrypt a folder or a file on your computer. So here's the deal with symmetric encryption. The big pro? It is super fast. I mean, it's perfect for when you're moving a lot of data around. But, and this is a big but, there's a huge problem. How in the world do you safely get that secret key to your friend in the first place without somebody else grabbing it? It's a real head-scratcher. So how do you solve that key sharing problem? Well, that leads us right into our next type, which we'll call the public mailbox, also known as asymmetric cryptography. Okay, this concept is just brilliant. Instead of one key, now you have two, a public key and a private key. Think of your public key like a mail slot on your front door. You can tell everyone your address, that's the public part. Anyone can come by and drop a letter in that slot. But only you have the private key to unlock the box and actually read what's inside. And this is the absolute backbone of modern internet security. You know that little padlock icon you see in your browser's address bar when you're banking online or shopping? That's it. That's asymmetric cryptography in action, making sure your connection is private and nobody's eavesdropping. So you can see the trade-off here, right? It totally solves that key sharing problem, which makes it way, way more secure for kicking off a conversation. But what's the catch? Well, all that heavy-duty security math makes it a lot slower than its symmetric counterpart. All right, let's switch gears to something totally different. We're talking about hashing now. And get this one isn't about locking and unlocking at all. It's all about creating a unique one-way digital fingerprint for your data. So how does this work in the real world? Okay, when you create a password for a website, the last thing they want to do is store your actual password in plain text. I mean, can you imagine the security nightmare? So instead, they take your password, run it through this special one-way function, and what comes out is a unique scrambled code. That's the hash. The number one place you'll see this is obviously in password storage, but it's also the absolute core technology behind cutting-edge stuff like blockchain systems. It's what makes sure all those crypto transactions are secure and can't be messed with. And this is the most important thing to remember about hashing. It is a one-way street. You can't reverse it. You can take your password, password123, and turn it into that long string of gibberish, the hash, but there is no way to take that hash and figure out that the original password was password123. That irreversibility is exactly what makes it so powerful. Okay, on to our final piece of the cryptography puzzle, the unforgeable signature or digital signatures. Now this one's not about secrecy, it's all about proof. Proving who sent a message and proving it hasn't been tampered with. The easiest way to think about it is just like signing your name on a paper contract. It's a clever mathematical trick that attaches your unique digital identity to a message, giving everyone undeniable proof that, yes, it really came from you, and no, it hasn't been changed one bit along the way. And this is absolutely critical for building trust online. When you e-sign a document or download a new piece of software, how do you know it's legit? A digital signature is working behind the scenes, giving you that confidence that it's the real deal and not some fake or a file loaded with a virus. Okay, so we've looked at these 4 different types of cryptography, but the real magic is that they almost never work alone. They're designed to work together, like different pieces of a suit of digital armor that protect you online. Let's make this real. Think about logging into your bank. First, you and the bank use the slow but super secure asymmetric crypto to shake hands and verify it's really you.
Once that secure channel is open, you switch to the much faster symmetric crypto to actually send your account info back and forth. Meanwhile, hashing is making sure your password is safely stored on their end, and to top it all off, digital signatures are verifying that every message is legit. See? They all work in concert. So, as you can see, this stuff is everywhere. It's the silent, invisible guardian that's constantly protecting our digital lives. And hopefully, the next time you see that little padlock in your browser, it'll mean a little more. You'll know the incredible science that's humming away behind the scenes, all to keep you safe.
Kind of makes you wonder, right? Now that we've pulled back the curtain on this one invisible shield, what other hidden technologies are out there quietly running our world every single day? Definitely something to think about. Thanks so much for joining me.